In this simulation, we will work out redox equations. To do so, we will add the half equations. One of them will be reduction half equation and the second one will be oxidation half equation. So adding up reduction and oxidation half equations will give us the net ionic equation, which is known as redox reaction. Let's start with this example. In this case, we have manganate 7 in acidic solution and we have iron 2 salts. The oxidant is manganate 7 and this means that it undergoes reduction. So we have gain of electrons. So notice that manganate will gain 5 electrons and it will be reduced to Mn2+. On the other hand, the reductant is iron 2 salts, Fe2+. So Fe2+ will be oxidized and it will lose 1 electron to become Fe3+. So when we write the electrons before the arrow of the equation, this means that we have gain of electrons, and when the electrons are written after the arrow on the product side, this means that there is loss of electrons. At the first step, we have to balance each half equation. At the first step, we will balance all elements other than oxygen and hydrogen. And then, to balance hydrogen, we will add H+. And to balance oxygen, we add H2O. And to balance the charges, we will add electrons. So this is the reduction half equation. MnO4- plus 8H plus 5 electrons will produce Mn2 plus 4H2O. This is a balanced half equation. Let's check now the oxidation half equation. Fe2 plus will produce Fe3 plus 1 electron. To be able to add these two half equations, the number of electrons must be the same in both half equations. So here we have 5 electrons and here we have only 1 electron. So we will multiply this whole half equation with 5 until we obtain 5 electrons. Once the number of electrons is the same in the oxidation and reduction half equations, we can add these two equations up to obtain the redox equation. So this is the redox equation. Notice that in the redox equation, we don't have electrons. However, of course, there will be transfer of electrons at the half equations. Let's take, for example, dichromate in acid solution. So again, here we have gain of electrons. This is the reduction half equation. So dichromate 7 is the oxidant. On the other hand, here we have loss of electrons. So this is oxidation, and thus the reductant is Fe2+. Again, notice that all elements and the charges are balanced at each half equation. Now we need to add these two up. Before adding them, we have to balance the number of electrons. Here we have 6 electrons, whereas here we have only 1. So how can we obtain 6 electrons at this half equation? Of course, we will multiply by 6. So now we have 6 electrons at the oxidation half equation and at the reduction half equation. So we can add them up, and this is the net ionic equation or the redox equation. Bromine will react with lithium. Bromine in this case is the oxidant and lithium is the reductant. So what should we do to be able to add these half equations? Yes, we must have equal number of electrons. So we will multiply here by 2 and now we will add them up, and this is the redox equation. Let's take this example. The oxidant now is iodine and the reductant is aluminum. At the reduction half equation, we have 2 electrons, whereas in the oxidation half equation, we have 3 electrons. So how can we obtain equal number of electrons? So we have to find a way to obtain equal number of electrons in both half equations. If we multiply the reduction half equation with 3, we will obtain 6 electrons. And if we multiply the reductant half equation by 2, we will obtain also 6 electrons. And now we can add them. So this is the redox equation. So it's not always the case that we will multiply only one half equation. we can also multiply the two equations to be able to add them up.